All right, welcome to chapter one. Yeah, let's go. All right, so this is the real number system, and yes, you can start laughing already because this is the world's funniest joke. Okay, it's not the world's funniest joke, but it's one of the funnier math jokes out there. What? You don't get it? Oh, congratulations. I will explain it to you. So, chapter one, the real number system. So there are real numbers and there are unreal numbers. The unreal numbers are also called imaginary numbers. So this I is called an imaginary. Imaginary, whoops. That's called an imaginary number. And this pi is, it's a type of real number. Real numbers are just any number that you guys can actually think of. So 1, 2, -3, 1/4, 3/5, 2.71, 1.00000003, 0.9999999 repeating forever and ever. All of those are example of real numbers. So I is an imaginary number, and it's telling pi, hey, be rational. Because technically I is a rational number. I is actually the square root of -1, which makes it a rational number. And saying, hey, you need to be rational because, in like an argument when someone's saying like, hey, yeah, you got to be rational. Yeah, well, here it is one number telling the other one to be rational. Because it's the square root of -1. That's right. That's why it's an imaginary number, because you can't actually have the square root of a negative number. Then you ask, well, why would we even have it? Well, it's got theoretical implications, and it's really fun because it's math. Just trust me. But it's not a real number, and pi is. So pi says, hey, get real, dude. Get it? Yeah. It's a good one. You're welcome. All right, so we are on section 1.1. Before we get to 1.1, though, I want you to go to page 3, pause this video, and look over pages 3, 4, and 5, and 6. So pages 3 to 6. Pause this video and look over those. Refamiliarize yourself with all of them. You don't have to do everything on there, but refamiliarize yourself with them. If you're like, hey, I want to, you can go and do some of those ones. But pause the video, look through numbers, pages 3, 4, 5, and 6. All right, and we're back. All right, so hopefully you remembered everything 3, 4, 5, and 6. If not, you're going to need to know that stuff for this. It'll be going back to last year probably for you. So we have, now we're on page 7, and we're working with rational numbers on the number line. Yes, I know that you're wondering, hey, does that mean we're working with I, the imaginary number, which is what? That's right, it's the square root of -1. Unfortunately, no, we are not working with I, because we're not working with imaginary numbers, and to be honest, you're not even really going to learn about imaginary numbers till high school. You're welcome that I'm teaching you anything about them early. Best teacher ever, right? All right, so we're on page 7 here. We're looking at rational numbers on the number line. So what is a rational number? A rational number, well, we're going to get into that a little bit more, and we're going to looking at what they look like on the number line. So if you're on page 7 here, you can see, hey, there are lots of big words in yellow here, so they're really important. So I'm just going to read through that top there. It says, previously you learned how to graph whole numbers and negative numbers on a number line. The set of whole numbers and their opposites is called the set of integers. So remember, whole numbers are something like 1, 2, 3, 4, dot, 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 67, dot, 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 keep on going forever and ever. Those are all whole numbers. Integers just means it's all of these plus their negatives. -1, -2, -3, -4, dot, 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 -67, and all the rest of them. So integers is all of them. So again, whole is just these. Integers is those and those. So is 1, 2, 3, 4, and 67, are those also integers then? Yes, they are both, because integers includes both sets of them. Reading on, the numbers on the right of the zero are called positive integers. Yep, that's these ones because they're to the right of the number line. If we had 0, those they would be over here because they're positive integers. And these ones on this side, on the left, that's what are they called? That's right, they're called negative integers. And then below that, it says in the gap between 0 and 1, you can write the proper fractions such as 1/4, 1/2, 3/5, and 9/10. So basically they're saying, hey, if you've got -1, if you've got 1 right here, yes, these numbers that are all right here, all those fraction numbers in there, they are still rational numbers. And same is true for these ones on this side as well. All right, next page, page 8. Find the absolute value of negative fractions and decimals. So the next question is then, oh, Mr. Bernal, what is negative? What's absolute value? I don't remember. Oh, I'm glad that you asked that question. Really weird that you asked it in that voice though. So absolute value is, anyone remember? It is the, I'm going to erase that because that's bad handwriting, not like that. It is the distance from, anyone remember? Yes, it's the distance from 0. Absolute value is distance from 0. So it says you might imagine that a mirror is being placed on the number line at 0, and then you see those examples on top page 8. As you look in the mirror, you see the images of positive integers. These images are the negative integers. In the same way, fractions such as 1/2, 13/5, and 10/3 each has an opposite mirror, the negative fractions, -1/2, -13/5, -10/3. So for all of them, if you're going to say, hey, what is the absolute value? Absolute value, remember, is distance from 0. So if I say, what's the absolute value of -3? Well, how far is -3 from 0? Okay, go ahead and draw this. 0, -1, -2, -3. Well, what is this distance right here? How far is this? Is the distance negative? Trick question. No, distance cannot be negative. So the distance is 3. What about if I said 5? What is the absolute value of 5? Well, 1, 2, 3, 4. Whoops, I didn't. That's actually 4. 5, we're going to say that's 5 right there. So what is that distance right there? Yes, it's still 5. So, Mr. Bernal, looks like we've got absolute value. Oh, wait, someone else has a question. What are these little signs right here along either side of those numbers? Why are you saying those with absolute value? Is that the question? Is that what it means when you have absolute value? It's the notation is that you put these little bars around it? Yes, very good question, Johnny. Anytime you have those little bars around it, that means the absolute value of this is what? So the absolute value of -3 is 3. The absolute value of 5 is 5. The absolute value of, my favorite color, navy, -268. Yeah, I don't know why I put that little thing on the front of the 2. -268 is, yes, that's right, 268. Whatever your absolute value is, it's always going to be positive because absolute value is always positive. So how does that work then if we're going to do it with fractions? Well, if you look at the top of page 9, if we're doing 8, it says find the absolute value of -11/12 and 26/15, not 25th like I was going to write. Well, absolute value, remember that's just the distance from 0. How far is -11/12 from 0? -11/12 from 0? That's right, it is 11/12 from 0. How far is 26/15 from 0? That's right, it is 26/15 because absolute value just means that you find whatever that number is and you find the positive version of it. And then on B, it says using a number line, show how far -11/12 and -26/5 are from 0. Which number is closer to 0? So then I do the 0. I'm going to make -1, -2, and I'm just going to show about where each of them is. So 11/12, or sorry, a -11/12. So you got to remember what the actual number. -11/12 is going to be a little bit greater than -1. So I'm going to say -11/12 is right there. And 26/25, that's what we're looking at, 26/25. Is it going to be almost -2? No, it's not. Why is that? Because this is a positive number. They asked, is which number is closer to 0. They're not talking about 1, 2. They're not talking about which absolute value is. They're talking about the actual numbers themselves. Actual numbers themselves. So I have, this is where negative 11/12 is, and 26 15ths, we'll think 15 goes into 26 almost 2 times, but not quite. So we're going to say it's about right here. And that is 26 25ths. Well, which one of those is closer to 0? Well, this one is less than 1 away from 0, and this one is more than 1 away from 0. So therefore, negative 11/12 is our answer. That is the one that's closer to 0. All right, if we look at guided practice, then it says find the absolute values of, which color do I want here? Let's do Poiple. Absolute value of 3 2/7, and the absolute value of negative 18/15. Absolute value of each of them. All right, well, absolute value of this one, you can pause these and then do them at home and unpaused. So I could say I'm going to convert this into a improper fraction. Remember, you multiply this and then you add that. So 3 times 7 is 21, plus 2 is 23, and I always put it over the denominator, so it's over 7. Or, hey, if I'm just trying to, I can just also do the original one, 3 2/7. That's how I'm figuring out the answer for that one. If I'm going to do the absolute value of this, could I turn it into a mixed number? Sure, I could. I'm not going to here, though. It's just going to be 18/15. Because remember, absolute value is always what? Yes, positive. And then graph the two numbers on a number line and indicate their distances from 0. Which number is farther from 0? Think, hey, 0. Remember the original number, 3 2/7. 1, 2, 3, 4. So 3 2/7 is probably about here. And negative 18/15, well, that's negative. It's greater than negative 1, but not by much. So I'm going to say negative, sorry, it's less than negative 1, but not by much. Because this would be negative 15/15. So negative 18/15 must be a little bit further back. And the question is, which number is farther from 0? Well, clearly this is a lot farther from 0. All right, and day 2, we're on the bottom of page 9 here. Express integers as a fractions in m over n form. Integers, and make them fractions, m over n. So now here it's talking about the fact that we have rational numbers. A rational number is any number that you can write it as this, m over n. So, hey, but that's a fraction, right? Well, what about the number then 3 or 4 or negative 63? Are those rational? You don't write those as fractionals. There's no m over n there. Well, yes, there is. M over n. So m is one number, and n is another number. So in this example, 3 would then become 3 over what? Because you need one number on top and one number on bottom. 3 over what? Yes, 3 over 1. You should remember that. 4 becomes 4 over what? Yep, 4 over 1. Negative 63 becomes what? Yep, negative 63 over 1. So even though we don't normally represent them as fractions, it is a rational number if you can represent it to be a fraction in some way, shape, or form. The only thing you can't do with that is 0, because you can't have 0 over 1. Sorry, you can have 0 over 1. That still works. But what you can't have is if it's the other way around, 1 divided by 0. Because if you have 0 of something, you can divide it into one group, because that one group has nothing. But if you have, what about if you have 1 of something? Can you have 1 of something and divide it into 0 groups? No, because then that would make them disappear. So n, your bottom number, cannot be 0. Remember, if I'm writing, you should be writing at home as well. N cannot equal 0. That is one thing that we have to always remember when we're doing integers and fractions and the m over n form. So if we look over on page 10 here, we've got A, B, C, and D. So A is 23, B is negative 45, C is 11 and 7/9, and D is, what is that, negative 16 over 21. So how do we do all of these? Great, I'm glad you asked that question. Well, this one's pretty easy, right? Just put it over 1. This one's pretty easy, right? Just put it over 1. This one, we just put it over 1. Uh-oh, that doesn't work. Can't do that. So what do we have to do? That's right, we have to turn to an improper fraction. Oops, that's erasing my beautiful work. So this was 11 and 7/9. Yep, 11 and 7/9. So I have to do multiplication here and add here. Remember, 11 times 9, 99, and this is 7/9. So 99 plus 7 is going to give me 106 over, what was my denominator before? Yes, 9. 106 over 9. Do I leave it as that? Well, I wouldn't if I could reduce it anymore, but I cannot reduce it. 9 does not go into 106. Think about it. 9 goes into 90. It goes into 99. So if we add another 9, that would be 108. So it does not reduce anymore. This is the simplest form that it can be. Then right here, negative 16 over 21. Well, it's already done, right? Kind of. I wrote it that way. So technically they have the negative here in the book because it's saying the whole number is negative. So you can do this one of two ways. You can say the top number is negative, or you can say 16 over negative 21. You can say the bottom number is negative. Doesn't matter which one. Either one of them can be negative. All right. Now we have, no, we're going to go with my color again. Got to practice 3 through 6. 3, 4, 5, 6. 3 is 11 and 1/6. 4 is 48. 5 is negative 5 and 4/12. And 6 is negative 25 over 10. So you can write those down, do them, and come back here and check your work. All right, and we're back. So this first one, I look at it and I'm thinking to myself, hey, I have got to multiply here first and then add there. 6 times 11, 66, plus 167 over 6. Done. Number 4, sorry, number 4. All I got to do is divide it by 1. Done. Number 5, got to do the same thing. Multiply here, add here. 5 times 12 is 60. 60 plus 4 is 64 over 12. And I'm going to put the negative on the top there. Am I done? No, I am not done. Why not? Anyone figure it out? Yes, it's because I have to figure out what number goes into both of those. So I am going to say, hey, I'm pretty sure 4 goes into both of these. If you can't recognize 4 right away, that's okay. You can do 2, divide by 2, and then divide by 2 again. 64 divided by 4. Well, I know 4 goes into 60 15 times, so it must go into 64 16 times. All divided by 4 is 3. Final answer is negative. Hey, Mr. Burnell, can we leave it as 64 over 12? Is that good? What do you guys think? Do I want things reduced, simplified, or not? Yes, I want them simplified. So I want this. Sometimes the back of your book will have answers that are like this. That's trash. Don't listen to that. I don't want that. Reduce your answers. I want this one, not this one. Number 16, number 6. Oh, look, it's done already, right? Wrong. Why is it wrong? Well, look at number 5. Why was 64 over 12 not good for me? Yes, because it's not reduced. And you kind of have to make either the negative on the top or the bottom. I'll put the negative on the top. That's why I just wrote that right there. What number do I divide by to make it smaller? Yes, 5 over 5. 25 divided by 5 is negative 25. Remember, don't use that negative. The negative is on the front here. Negative 25. Sorry, that's not negative 25. It is just negative 5. And 10 divided by 5 is 2. Negative 5 over 2 is the final answer. All right, and let's go to top page 11 here. Now we're doing the same thing, but we're just doing it with decimals. Your boy. All right, we got decimals on the top. We've got 4/10. I'm going to do negative 186 hundredths, negative 186 thousandths, and 30.5. I'm going to skip D because it's pretty similar to the other ones. So here, all I do, yep, 4/10, because 4/10, 4/10, is that done? No, why not? That's right, because it's not reduced. How do I reduce it? Divide by 2/2 on the top and bottom, and it becomes 2/5. Is that all the way reduced? Yes, it is. All right, with this one, negative 186 thousandths. Well, if you actually set it the right way, instead of saying negative 0.186, go negative 186 and thousandths, so it's over 1,000. Is that done? No, we got to divide by, well, I'm going to 2/2 right away, because I know both of them are going to that. 186 divided by 2, let's see, 2 goes into 18 9 times, so it must be 93 and 500. And I'm going to put that negative on the top still. And I'm pretty sure that's where it stays, because 93 is an odd number. Odd numbers don't go into 500. At least not 93 doesn't. Last one, 30 and 5/10. Remember, you can turn that into 30 and 1/2, and then multiply and add. Yep, 30 times 2 is 60, plus 1, 61/2, and that is my final answer. Done. All right, if you look at the guided practice on bottom of page 11, we've got 11.5, negative 7.8, and I'm going to do just number 10, so negative 0.125. Pause this, do those, turn them into fractions, turn them into m over n, and then come back here. And we're back. All right, so for this one, 11 and 5/10, it turns into 11.5. Multiply there, add there. 11 times 2 is 22, plus 1 is 23. What's it over? Denominator is 2. Done. Negative 7 and 8/10. Well, I'm going to go to negative 7 and 8/10. Actually, I'm going to change it to negative 7 and 4/5 right away, because I know eventually, if I have 8/10 here, I'm going to be able to reduce it. So I'm just going to reduce it right away. 7 times 5 is 35. 35 plus 4 is 39. 39/5, and it is negative. Got to remember that. And 39/5, that's my final answer. See, reducing here meant less work for me later. Try to recognize that stuff right away so you don't have to do more work later. Negative 0.125, or negative 125 thousandths. Well, what does that look like? It should look pretty familiar, actually, because 125, think about it, that's like 12.5 of 100. 12.5 goes into 25, 25 goes into 100. So it's actually going to be, if you divide by 125 on each, you're going to get 1/8. But remember this negative here, so it's negative 1/8. All right, last section here. Top of page 13. Rational numbers can be located on the number line easily. So locate the rational numbers 3/5 and negative 2.4 on the number line. 3/5, negative 2.4, 2 and 4/10. So always start here with your 0, and then I want you to make your hash marks on either side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can go negative 1, negative 2. And I've got to look at here. 1, 2, 3, 4. So 1, 2, 3, 4, 5. Yep, that'll do it there. And negative 2.4 would be right here. Oops, negative 2.4, 2 and 4/10. This should be a little bit prettier than mine. What I had there, obviously I didn't have to go that far out. And then 3/5, it's going to be less than 1. So that means I draw this into 4 sections. 1, 2, 3, 4, 5. This, you'll also notice I only drew into 5 different sections, because 4/10 is the same thing as 2/5. And so I just put it on the second section of that. I could have drawn out 10 sections and put it on there, but I didn't really need to. You also could have converted this and said, hey, negative 2 and 4/10, that's 2 and 2/5. 5, not 2 there. Negative 2 and 2/5, and then you would have gotten the same thing here. Probably would have been easier to do it that way. Anyway, so if I'm finding 3/5, 1, 2, 3 over 5, that's how you can show yours there. Yes, I want to see specifically where it looks like on there. You can see in the book on bottom of page 12, they exaggerate a little bit more. They kind of stretch their number line out a little bit more. That's probably a good thing to recognize. I just automatically draw my 0 first and then try to figure out everything else after that. So if you know, hey, negative 2.4, you can maybe make your spaces a little bit bigger than what I did, because that made it a little more challenging. All right, and guided practice. Locate the rational numbers negative 1.5 and 15 over 4 on a number line. I'm not going to go through all of these. You can do a couple of them and then look in the back of your book to check over what they look like. But I'm going to have you guys start on your assignment now. Thanks. Let me know if you have any questions.